Welcome everybody. It's Ramchandra from Gate Maths Concepts MRCL. Until now we have completed 4 videos. In the fifth video we will be continuing with simultaneous equations, inverse and rank of the matrix. Welcome everybody for today's lecture number 5 on the topic linear algebra. In the last lecture we have introduced the concept of simultaneous equation, elementary row and column operations on a matrix, and little bit of inverse of a matrix. And in this lecture, I am going to further extend details about finding the rank of the matrix, condition number of the matrix with the elementary row and column operations. Today, lecture number Linear Algebra, lecture number 5. We will be covering rank of a matrix, elementary operations, extended beyond 3 by 3 matrix, condition number of a matrix, and with the help of elementary operations to find the determinant of a matrix. Now, in this lecture, let us take an example of 4 by 4 matrix and we will do all these operations and let us see how the concepts can be clear. Till now we have dealt with 2 by 2 matrix and 3 by 3 matrix. Let us expand our scope of study to 4 by 4 matrix. Regarding this 4 by 4 matrix, I have already released a short video on my channel Gate Maths Concepts MRCL. In that I have only shown the steps. I have not explained, because in the short video I cannot explain the things. I can only show the video for about 45 seconds. Here I will explain the process in detail so that you can appreciate the easiness with which we can find the rank, we can find the inverse, we can find the condition number, and we can find the determinant even for a bigger matrix of 4 by 4 size. The same example I will be taking, and let's proceed further. Let A be a matrix (1, 2, 4, 6, 8, 10, 12, 14, 2, 3, 5, 7, 10, 12, 14, 16. Now, as I have told you previously, what we are supposed to do? We have to make all the elements either below the principal diagonal, which is shown in blue line here, or above the diagonal, principal diagonal, zeros. That means, or else we can make all the elements above and below the principal diagonal as zeros. That is the aim of this elementary operations. To convert this 4 by 4 matrix into either a triangular matrix or a diagonal matrix. Let us start. Let us start with R1. We'll take R1 and we'll operate R1 on the other rows so that the first column, except the first element of the first column and row, all others in the first column will be 0. Now let us do. Here we'll operate what we'll operate? R1, R2 minus 8R1. So that is this 8 will go, it will become 0. R3 minus 2R1. R4 minus 10R1. We are operating on R2, R3, R4 using R1. What will be the result? 1, 0, 0, 0. And the first row is the operator, hence it will not change. In the second row, R2 minus 8R1. This is 10 minus 8 into 2. 10 minus 8 into 2. This will be 12 minus 8 into 4. 12 minus 8 into 4. This will be 14 minus 8 into 6. Agree? Next, R3 operating on R3. R3 minus 2R1. R3 is, here it is 3. 3 minus 2 into 2. 5 minus 2 into 4. 7 minus 2 into 6. Now let's come to R4. 12 minus 10R1 minus 10 into 1. R4 is 14 minus 10R1. That means 10 into 4. Then 16 minus 10 into 6. What will be the result? 1. Here it is 2, sorry. 2, 4, 6. And here it is 0, 0, 0. 10 minus 16 is minus 6. 3 minus 4 is minus 1. 12 minus 10 is 2. Sorry, 10 into 2 here it is. It is minus 8. Then 12 minus 32 is minus 20. 5 minus 8 minus 3. 14 minus 40 minus 26. Then 14 minus 48 minus 34. 7 minus 12 minus 5. 16 minus 60 minus 44. After 1, this is step 1. After step 1, the result is this one. Now, let us do the step 2. In step 2, what we have to do? We have to make the second column, the elements below, second column, second element. Below the second column, second element, the elements to be made 0 in the second column. That means these should be made 0. Next target. These should be made 0. To make this 0, what we have to do? Either we can operate, it is better to operate R2. Because by operating R2 and R3 and R4, we will not have any impact of changing the first column zeros. Now, next step is to operate R2. First we have operated R1 and made all the first column elements 0 except for the first row and first column element. Now, in the second step, we will be operating with R2 and making R3 and R4 second column elements as 0. Let us proceed. This is step 2. In step 2, what we have to do? Here you see R2 is minus 6, and to make minus 1 as 0, by adding or subtracting some multiple of minus 6, I think in step 2, the given matrix is, which we have obtained, the matrix in step 1, that is 1, 2, 4, 6, 0, minus 6, minus 20, minus 34, 0, minus 1, minus 3, minus 5, 0, minus 8, minus 26, minus 44. Let us see whether it is correct or not. 1, 2, 4, 6, 0, minus 6, 20, minus 34, 0, minus 1, minus 3, minus 5, 0, minus 8, minus 26, minus 44. Now, to make minus 1 and minus 8 as 0, what we have to do? By operating with minus 6, we have to deduct from R3 minus 1 by 6 R2. Do you agree? Just. Next is, for making minus 8 as 0, R4 minus 8 by 6 R2. Let us see, operate this in the step 2. What will be the result? 1, 2, 4, 6. First row will not change. Second row will not change. Because we are operating with second row, minus 20, minus 34. Now, third row. First element is 0. Here it will be 0 because minus 1 minus of minus 6 by 6 is minus 1 plus 1, that is 0. Minus 8 minus of minus 8 by 6 into 6, that is plus 8, that will be 0. Now, here it comes value minus 3 minus of minus 20 into 1 by 6. Here it will be minus 5 minus of minus 34 into 1 by 6. And here it will be minus 26. This is R4 minus 8 by 6. It is not 1 by 6. It is 8 by 6. Minus of minus 3 into 8 by 6 minus 44 minus of 5 into 8 by 6. This will be the value of the matrix. If you see this, 1, 2, 4, 6, 0, minus 6, minus 20, minus 34. Now, here it is 0, 0, 0, 0, minus 3 minus 20 by 6 or minus. That means 20 by 6 will become plus. Plus 10 by 6 is plus 5 by 3. That means 20 by 6 is 5 by 3. Agreed? 10 by 3, sorry. 20 by 6 is 10 by 3. This means it will be 10 by 3 minus 3. This will be 10 by 3 minus 3. Now, what will be this value? This is plus 34 by 6 is 17 by 3. 17 by 3 minus 5. This will be 17 by 3 minus 5. This value. Now, next comes 26 minus 3 into 8 by 6. 8 by 6 is 4 by 3. 4 by 3 into 3 is 4. 4 minus 24 by 6. 8 by 6 into R2. Sorry. I made a mistake. Here it is not 8. It is 20. R2 element is 20. It is not 3. It is 20. 20 into 8. Here also it is not 5. It is 34 into 8. Very sorry. It's a little small error. Now, you see. Minus 26 minus of 20 into 8 by 6. 20 into 8 by 6 minus of is 20 into 8 is 160. 160 by 6 is equal to 80 by 3. 80 by 3 minus 26. This will be 80 by 3 minus 26. What will be its value? 34 into 8 by 6 is 4 by 3. 34 into 4 is equal to 136. 136 by 3 minus 44. Then this becomes 1, 2, 4, 6. In this only arithmetics is involved. We should be a little bit careful about the arithmetics. That's all. 0, minus 6, minus 20, minus 34. Then this is 0, this is 0. 10 by 3 minus 3 is equal to 1 by 3. 17 by 3 minus 5 is equal to 2 by 3. Then this is 0. This is 0. This is 80 by 3 minus 26 into 3 is 78. That means 2 by 3. And 136 by 3 minus 144 is 132. 136 minus 132. This is 4 by 3. You see the result. Very good result here. When we divide, if you see, R3 is 0, 0, 1 by 3, 2 by 3. R4 is 0, 0, 2 by 3, 4 by 3. Now, as an elementary operations, we can even divide also. Let me divide. Under elementary operations, let me divide R4 by 2 and otherwise let me multiply R3 by 2 and deduct from R4. Next operation, step 3. This is step 2 is over. Now we will go for step 3. In step 3, what we will do? What is the answer in step 4? It is 1, 2, 4, 6. Now in step 3, it will be operation, only one operation, that is R4 minus 2R3. You just see, first we have taken R1 and in the first step we have taken R1 and operated on R2, R3, R4 and made zeros. In the next step, second step, we operated with R2 and made maximum zeros. Then in the last step, we will be operating R3 and make maximum zeros in R4. Let us see what happens. R1 will not change. R2 will not change because we are not operating them. R3 will not change because it is the operator. Now we are operating on only R4. 0, 0. 2 by 3 minus 2 into 1 by 3. That is 0. 4 by 3 minus 2 into 2 by 3. That is 0. It is a very, very good result. You can recollect my lecture number 4, in which I have told you that if one of the rows becomes 0, then what happens to that matrix? This is the example which I have taken arbitrarily and found that after elementary operations, one row is vanished. One row has become 0. One row is vanished. What does this mean? You please try to understand the concept of simultaneous equations. What does it mean? For example, let us take a 2 by 2 simultaneous equation. 2x plus 3y is equal to 5. This is one equation. Another equation is 0x plus 0y is equal to 0. There are two equations, two unknowns. Can we solve this equation? Please think over for a minute. Can you solve this equation? Then if it can be solved, how many solutions are there for this? This is what is happening in the previous example, this one, 4 by 4 matrix. One row is totally 0. This has a solution. This system has a solution, but it has infinite solutions. Because only valid equation is 2x plus 3y is equal to 5, which says that 2x is equal to 5 minus 3y. Agreed? Then we can choose any value of x and any value of y So that 2x into 2x plus 3y becomes 5. Are you able to understand? It need not be, for example, solutions. Solutions for that these solutions. Let me say x is equal to 1, y is equal to 1 is a solution. X is equal to 0, y is equal to 5 by 3 is also a solution. X is equal to 5 by 2, y is equal to 0 is also a solution. That means on a real line of infinite number of combinations, there are infinite solutions. This type of matrix determinant is equal to 0 and infinite solutions. Please try to remember, if a matrix is given and we are asked to find the behavior of that matrix and simultaneous equations are given, we are asked to find out the behavior of the simultaneous equations. Then if the situation operate the elementary operations, row and column operations on this matrix and see whether determinant is 0. If determinant is 0, it doesn't mean that there is no solution. There will be a solution, but it will not be a single solution. It will be infinite number of solutions will be there, like as above. Now you understood? If this type of matrix occurs to you, you come across this type of matrix, you can say that infinite number of solutions are possible for this type of matrix where one of the rows is 0 or one of the columns is 0 and determinant is equal to 0 for a triangular matrix or for a diagonal matrix. Please remember that. This product of elements of principal diagonal is equal to determinant is only valid for a triangle matrix or a diagonal matrix of this form which solution has come, and either the total number of column, either the one of the columns has total zeros or one of the rows has total zeros, then the system of equations will have infinite solutions. That's what is today's conclusion. Now, let's go further. There is one concept called characteristic equation. Characteristic equation is nothing but an equation obtained from the matrix formed by A minus I lambda, and the determinant of that is equal to 0. Now let's go to the concept of, now you have understood how to take the inverse of a matrix with elementary row operations and how to check the simultaneous equations with row and element operations, and next is how to say that whether inverse is existing or inverse is not existing. In our previous case, what is this? because determinant is equal to 0, it implies inverse does not exist rank after elementary operations. Whatever the matrix left over without all zeros in a row or column, without all zeros in a row, is called the rank of the matrix. What is the rank of this matrix? Here one, it is a 4 by 4 matrix, out of which one row is totally 0. Hence it becomes a 3 rows. 3 rows are only having a valid values, the elements of 3 rows. Other things, they don't have. 4th row is totally 0. Hence, rank of the matrix is equal to, this is the rank of the matrix. A row is almost, a row should be 0. If a row is a 0, then we'll reduce the size. Now, rank of a matrix is equal to 3. Inverse does not exist because determinant is equal to 0. Now let us find out the condition number. What is condition number? Determinant of the original matrix divided by determinant of inverse of a matrix, inversed matrix. Determinant of original matrix, let us say something. And determinant of inversed matrix in this case is 0 because the inverse does not exist. Then the condition number in this case is infinite. What is the meaning of condition number? Condition number gives an insight that the system of equations have a system of equations have a better sense of solution. If the condition number is low, system of equations will have the better sense of solution. If condition number is high, as it increases, the solution becomes erratic. Because here condition number is going to infinity, the solution is here is erratic, it's not correct, it has infinite solutions. That is the meaning of the condition number. Condition number, it can be dealt in advanced matrices, not actually in GATE syllabus, but however, I had given small introduction about the condition number. By chance, if it is asked for in the examination of this type of examples, tricky examples, you can definitely answer this question like this. And this is about the solution of my shorts video, which I have given the direct steps and solutions, whereas now I have explained the process here. I don't have luxury to explain in 45 seconds the process, but here I had the luxury to explain it. And if you want, you can see my shorts and short video and you can take a note from that. Now, let's go for characteristic equation. As I told you, characteristic equation is nothing but equation derived from the determinant of A minus I lambda. that is equal to 0. From the lecture 4, if you refer, in that I have explained about what is the meaning of this A minus I lambda. Now, let us go for let us go for one small example, how to find out the characteristic equation. I will tell the process. Let A is equal to 1, 3, 7. These are all arbitrary numbers which I have taken. They can be anything which I have taken arbitrary numbers. For explaining you, 3 by 3 matrix, we moved from 2 by 2 to 3 by 3, from 3 by 3 to 4 by 4 also. This way we have to expand our knowledge. Now, A minus I lambda is equal to 0 implies what is I here? I is nothing but unity matrix, elementary matrix, that is 0, 1, 0, 0, 0, 1. Don't worry about my language, please worry about the contents and the explanation what I am giving you. Now, A minus I lambda is equal to 0 implies what is A? 1. 1, 3, 7, 4, 2, 3, 1, 2, 1 minus I lambda. When I multiply some matrix with a scalar quantity, I have told you in the lecture 1 itself, it will be multiplied wholly. Lambda 0, 0, 0 lambda 0, 0, 0 lambda. When you subtract one matrix from another matrix, the respective elements, corresponding elements will be subtracted. The result will be 1 minus lambda, 3, 7, 4, 2 minus lambda, 3, 1, 2, 1 minus lambda. This is the matrix. Okay. Now we have to find out the determinant of that matrix. What will be the determinant? One minus lambda into 2 minus lambda into 1 minus lambda minus 2 into 3. This is 1. Minus 3 into 4 into 1 minus lambda minus 1 into 3 plus 7 into 4 into 2 minus 1 into 2 minus lambda. This is equal to 0. Now, you will get an equation in a cubical form and that equation sum a into lambda cube plus b into lambda square plus c into lambda plus d is equal to 0. In this form you will get the equation. This is what is called as the characteristic equation. This we can even write it as a lambda cube plus b lambda square plus c lambda is equal to minus d. Minus d into 1. If I replace lambda with A, what happens? Or else we can even write A lambda square plus B lambda plus C is equal to minus D by lambda. We can even write like that. Let us replace, or else we can even write A lambda square plus B lambda plus C is equal to minus D into lambda to the power of minus. If you replace lambda with A, what happens? A into A square plus B into A plus C into I is equal to minus D into inverse of E. From this, can you find out the inverse? A inverse is equal to 1 by minus D into A square plus BA plus C. This is another way of finding the inverse. If you know the characteristic equation, from that also you can find out the inverse of a matrix. This is also another way. Previously we have done it with elementary row operations and column operations. Inverse we have from characteristic equation we are able to find out the inverse. And for example, in the GATE examination, usually they may say that what will be the value of A lambda cube plus B lambda square plus C lambda? So that once you know the characteristic equation, you need not calculate whatever is there on the left hand side. You can directly put minus D into I. That's all. That will be the value of this. You understood? This is how in GATE examination concepts are checked. The details about how the characteristic equation is being used are eigenvalues are by lambda 1, lambda 2, lambda 3 are the eigenvalues. The product of the, if anybody wants us to find out the determinant of a matrix given 3 by 3, we'll find out lambda 1, lambda 2, lambda 3 and say that the product of the lambda 1, lambda 2, lambda 3 is determinant of the matrix. And the characteristic equation is so and so, and the inverse is so and so from the characteristic equation. If somebody asks us to find out A into lambda cube plus B into lambda square plus C into lambda, that is A cube plus B A square plus C A is equal to what, means that will be minus D into I. From the characteristic equation we can find out the A. That we can even say A cube plus B A square plus C A is equal to minus D into A inverse. Sorry, minus D into not A inverse, it is, I'm very sorry, minus D into I. This way also, somebody in GATE asks you, they give a 3 by 3 matrix and asks you, find out the value of A cube plus B A square plus C A. They will have already ABC values with them. And they say, find out this value, means you just see the characteristic equation. If it can be converted into this form, multiply that characteristic equation, last value, D value, and multiply that minus D value with unit matrix, and that will be the answer. This is how the equations, the polynomials of matrices can be solved. Further about the characteristic equation, polynomials of the matrices, and finding A to the power of 4, a to the power of 5, a to the power of 3, a square, a cube, a to the power of 4. Very easily. How we can do that also I will explain you in the next class. Best of luck to everybody. Be very, very careful in numerical calculations so that numerical error may result in the error in the answers. Numerical errors should not be done. We should be very careful. And this is the concept about the eigenvalues, then simultaneous equations, determinants, rank of a matrix, and condition number and characteristic equation. We'll go further in deep in the next lecture, Linear Algebra 6. Best of luck to you. Thanks a lot for listening to me.